Dr. Sagai Sudarsan, Associate Professor, Department of Mechanical Engineering, Rowan College of Engineering and Technology. Now we are going to discuss about the theory of metal cutting and cutting tool process. It is related with the manufacturing technology for the 4th semester Mechanical Engineering students, unit number 1. So, theory of metal cutting, machining. In this term, applied to all material removal process, metal cutting, the process in which thin layer of excess metal, like chip, is removed by a wedge-stable single point or multi-point cutting tool, which define geometry from a workpiece through a process of extensive plastic deformation. The cutting itself is a process of extensive plastic deformation from a chip that is removed afterward. The basic mechanism of chip formation is essentially the same for all machining operation. Assuming that the cutting action is continuous, we can develop so-called continuous model of cutting processes. The cutting model shown above is oversimplified. In really, chip formation occurs not in plane but in so-called primary and secondary shear zones. The first one is between on the cut-off chip and the second one along the cutting tool face. This is the work from the system Smith diagram shows the workpiece force tool plays on the workpiece as per the direction of the image, the chip will be formed. Single point cutting tool, as distinguished from other cutting tools such as the cutting edge is ground to suit a particular machining operation and may be sharpened and reshaped as needed. The ground tool, which is held rigidly by a tool holder while it is cutting. Back rack is to help control the direction of the chip, which naturally goes into the work due to the difference in length from the outer and inner parts of the cut. Side rack, along the back rack, controls the chip flow and partially contracts the resistance of the work to the movement of the counter and can be optimized to suit the particular material. Having a reduced also strengthening a tip, a sharp point being quite fract. So this is the tool bit geometry systematic diagram. So in view, from you are looking the in view, the tool like this. Once the edge is sharp, we can able to remove the material from the workpiece is very easily. So all the other angles of the clearance, in order to that the part of the tool besides the actual cutting edge can touch the work. The front clearance angle usually and degrees, while the side clearance angle is 10 to 15 degree and partially depends on the rate of feed expected. Minimum angles which is do job required are advisable because of the tool gets weaker as the edge gets knee due to the listening support behind the edge and the reduced ability also absorb heat generated by cutting. The rate of angles can be top of the tool need to precise in order to cut, but to the cut efficiency there will be an optimum angle for back and side rack. Forces in machining. If you making free body analysis of the chip, forces acting on the chip would be as follows. A cutting tool side due to the motion chip against tool, there will be a frictional force and a nominal force. Support that a material side thickness of the metal increase while the flows from the uncut off position. The thickness increase due to inner planar chip between different metal layers. There should be a shear force to support this phenomena. According to shear plane theory of metal layer, chip happens in single plane called shear plane. So shear force acts on the shear plane. Angle of shear plane is can approximately determined by using a shear plane theory analysis. So forces acting on the chip on tool side and shear plane side. Shear force on shear plane can be determined using the shear strain rate and proportional of the material. A nominal force F1 is also present perpendicular to the shear force. The resultant force are at cutting tool side and metal side should be balance each other in order to make the chip in equilibrium. Direction of the resultant force are is determined as shown is the systematic diagram. Types of chips. There are three types of chips are the commonly produced in the cutting: discontinuous chip, continuous chip, continuous chip with the built-up edge. A continuous chip comes of small chunks of particles. When we get is the chip, it may be indicate brittle work material, small or negative rack angles. Then continuous chip looks like a long ribbon with a smooth shining surface. Ductile work material, large positive rack angles. So fine knead and high speeds continuous chips built up with the edge with still look like a long ribbon. Work materials like mild steel, aluminum, cast iron, etc. So depends upon the material the chip may be differ. Chip control. Discontinuous chip are generally desired because they are less dangerous for the operator. Do not cause damage to workpiece surface and measuring tool can be easily removed from the workpiece, can be easily handled and disposed after machining. There are three principal methods to produce the favorable discontinuous chip: proper selection of cutting condition, use of chip breakers, changes in the work material properties, chip break and chip kernel may be protected by use of called chip breaker. There are two types of chip breaker: external type or inclined observation clamped to the tool face. Internal type, integral type, a groove ground into the tool face or blood formed into the tool face. Cutting tool nomenclature. This is the systematic diagram of the cutting tool nomenclature. So the main thing, the angle, cutting tool angle is very important to produce the chip or metal removal process. Once the angle is very accurate, so metal remove done by with the easy manner. Back triangle is to help the control the direction of the chip, so which naturally covers into the work due to the difference length of from the outer and inner parts of the cut. It is also help contract the pressure against to the tool. Side rack angle along the back rack consists of chip flow and partially contracts the resistance of the work of the movement. The nose radius makes of the finish of the cut smoother, can also overlap the previous cut and eliminate the peaks value. Having a radius also strengthen the tip, a sharp points being quite fatigue. Orthogonal metal. So this is a systematic diagram of the orthogonal metal cutting. So metal cutting edge of the tool is perpendicular to the direction of the tool traveler. The direction of the chip flow is perpendicular to the cutting edge. The chip coil is a tight flat spiral. For same feed, the depth of cut force which shears the metal acts on the similar areas. So the life of the tool is less. Produce sharp corners, smaller length of cutting edge is a contact with the work. Generally, parting off of lathe, broaching and slotting operation are done in this method by using the orthogonal metal cutting. Oblique metal cutting. The cutting edge is inclined at the angle less than 90 degree to the direction tool travel. The chip flows on the tool face making an angle. The chip flow sideways is long. The cutting force act on the larger area, produce a chamber at the end of the cut. For the same depth of greater length of cutting edge is contact with the work. The method is cutting is used almost all machining operation. These are the way to metal removing basic functions. Thank you.